Right, so we went through all of the review sheet that I put up there, but there was a couple things that were not on there. And they were the inflation calculator and the hourly minimum wage. So I want to go over those, and then if you have any other questions, but we probably will stop early today unless you have a lot of questions. First thing, I talked a little bit about it before class, but in case you came on after that, we will get onto WebEx and then I will give you the password. You'll open up the exam and then you can work on it from there. You do not have to print it. You can write it out on paper and then you'll just either take pictures of it or scan it and put it onto Blackboard. You need to post it onto Blackboard before you sign out. You also have to have your video on. I don't want to see words, I want to see people. That way I know there's no one in the room with you. I mean, you're getting your notes and your calculator and your computer. You don't need another person. And so I just need to be able to see that. Oh, the other thing I would make sure you do before you start class is have your windows open. Like, open the inflation calculator and have the link up here. That way you can just click on it. It doesn't take time to load. The same thing, I have the other one over here. And you can bring up the hourly minimum wage. That way those will come up quickly for you. Because you will need both of those. Yeah, also updating your calculator, your computer, always try and open it ahead of time, just in case. But if that happens, then during the test, don't worry about it. Just send me a text and say my computer's doing an update or I can't get on, but I'll be on as soon as I can. And that's fine. There will be a password. I'll put it into the chat. That way, if you come in after people are already on, you can just look through the chat and get it, or just ask me and then I'll type it in again. Any questions on that? So before you log on, get your calculator, your inflation calculator, and your history of minimum wage up on your screen, and then go on to WebEx. That'll be a separate link. That way you can switch back and forth easily. Any questions? You don't have to write the whole question out. You can just put number 1 and show all your work, and then write your answer. Any questions? Since we're on the minimum wage calculator, we'll talk about this one first. When you have the minimum wage, these values here tell you when it changed. So on October 24th, 1945, minimum wage changed to 40 cents. Every time in there until January 25th of 1950, it was 40 cents. On this day, it changed to 75 cents. So if we said January 1st, 1950, that's in between here, so it was still 40 cents. It had not changed yet. And that's why they don't have all those values in between. They only put when it changed. So if we wanted January 1960, January 1960 would be between these two. So it was $1. It didn't change until September of 1961. So January 1960, it would still be $1. Any questions on the hourly minimum wage? Okay. I had a problem using it from, I took a couple problems from last year's exam, but it says using the federal hourly minimum wage, find each. The hourly minimum wage for July 24th, 2007. So July 24th, 2007. And July 24th, 2007 happened to be a day that it changed. So it was 585. Then I had July 24th, 2008. Now on your exam, it definitely will not have the exact date because I want to make sure you understand the values between it. July 24th, 2008 is another day when it changed, and it was $6.55. Any questions on how to use the hourly minimum wage? Since we were on minimum wage, we're doing number 3 first. So using the federal hourly minimum wage, and we found the two values. Notice there's a blank. When there's a blank, you're probably not writing a sentence. You would write a sentence, it'll say explain. So anytime you see a blank, just fill in, and then if it asks you to explain, then you would explain. That kind of helps you know when to write a sentence or not. But if you're not sure, just write a sentence.
Is this a question from the test or is this like in our notes?
This is a question from an exam from last semester.
Oh, okay.
I just grabbed a couple because in the review, we didn't use the inflation calculator. I didn't have it in there and I didn't have the minimum wage. So I grabbed a couple from my last exam.
Oh, okay. Thank you.
And then I would have you do something, whether it's absolute change, relative percent change. This one asks for relative percent change. And so we would find relative percent change. Remember the formula is new minus old over old. And since they want the percent, you multiply by 100.
So I'm sorry, I joined a few minutes late. This was just a review.
Yeah.
Okay.
Because we finished the review sheet last class.
Yeah.
And so it didn't have the inflation calculator and the hourly minimum wage. So I wanted to go over those.
Okay.
So I just grabbed some. I had a busy, hectic day yesterday. And so I didn't have time to make more outline problems. So I just grabbed them from last semester's exams. My daughter said not to reuse those questions anyways because they're probably on the internet. So might as well use them to review it. Okay, relative percent change. New 655 minus the old divided by the old times 100 to make it a percent. You're entering it all at once. Unless you have a fraction bar in your calculator, this has to have parentheses. My calculator doesn't have a fraction bar.
So I subtracted those and I got 0.7.
Okay.
Is that right?
Uh-huh. And then you divide by the 585.
Yeah.
And multiply by 100. You get 11.9658. If we were going to round to, because this is a percent, if we were going to round to the 10th, this 6 would actually make this a 0 and this a 12. So it's approximately 12%. Explaining what this value tells you. The minimum wage from 2007 to 2008 increased by 12%. Any questions on that? I think this is the year where they were trying to catch up with inflation. It was within 1 year, it jumped 12%. And I think this is where they were trying to catch up with the inflation rate. Any questions on that? Normally, within 1 year, it's not that big of an increase. Any questions? I went with this one first for those who came in after because I had this hourly minimum wage up. So we're going to do these two also. Any questions on this one? Okay. Looking at number 1. This one you'll want to bring up your inflation calculator. And this is an underscore. It's not a space. And so it says, if the Mustang cost $2,368 in May of 1964, what is the cost in May of 2017? Notice there's a blank, so you wouldn't have to write a sentence for this one. Now, absolute change, I have a blank, but then I felt to explain what it tells you, then you're writing your sentence. Okay, so first we go to the inflation calculator. We're going to use 2,368 for May of 1964 and find out what it cost in May of 2017.
So we're just putting that in the inflation calculator?
Yep, so we'll go to our inflation calculator. And put 2,368, and it was May 1964. And then May 2017. So a Mustang that cost 2,368 in 1964 would cost $18,754.94. Any questions on using the calculator? It asks for us to find the absolute change. How do you find absolute change?
You subtract the new amount with the old amount.
So we would subtract the two. And we get $16,386.94. And because absolute change keeps the same units, these were in dollars, so this is dollars. The 1964 Mustang increased its value by $16,386.94 in 2017. So I wanted a sentence that lets me know that you understand what the absolute change is finding. And in this case, absolute change keeps the same unit, so we're talking about dollars. And when we find relative percent change, it's telling you the increase as a percent. Any questions on that? The next question says to go to the inflation calculator, which is the same one. What is the inflation rate from January 2006 to January 2007? And I won't give you, the one homework problem where there was one of the years wasn't in our inflation calculator. The years will be there. You will only use this one. And that's why I said you should have it open ahead of time. It's the only one you're going to use. What is the inflation rate from January 2006 to January 2007? Inflation rate is relative percent change. But before we can find the relative percent change, we need to put in values for January 2006 and 2007. So we'll go to the inflation calculator.
Are we using the minimum wage chart to
You wouldn't have to for this one.
Oh.
We'll just use our inflation calculator. We can put any value in the start and then find out the value at the end and then just find your relative percent change. Remember the one problem where we put in $1, we put in 100, we put in 10,000?
Oh, right, yeah. Oh, okay.
So
Thank
we
you.
put in 100. And we're going from January 2006 to January 2007. So January. So I used the 100 because I can see the percent right in it. But you could put any value there. You could put $1 and see the value of $1. Your percent will be a little smaller. It won't show as many decimal places. I think 100 looks good. So it's 2.08. But I'll show you how to find that. So we put in 100 and we got 102.08. I'm going to go back to my paper. But is there any questions on using the calculator? Okay.
So we're finding the relative percent change.
Mm-hmm.
Okay.
So inflation rate means relative percent change. This would be the old value. We put in 100 and we got 102.08. Now, since we use 100, this is the answer, 2.08%. But to double check, the new was 102.08 minus the 100 divided by the 100, and then to make it a percent, we multiply by 100. So the inflation rate is 2.08%. Any questions on that? In 2006, a person was making $52,000. In 2007, he received a raise and is making $53,040. Looking at the inflation rate found in Part A, 2.08, and he buy more in 2007 than he did in 2006. Explain, being sure to state what percent his raise was. So we want to know what percent his raise was, relative percent change. Over here, in order to be able to spend more money, his raise needs to be larger than this. If his raise is larger, then he can buy more in 2006 than he can in 2007 than 2006. If it's less than this, then he can't buy more. If they're the same, he can buy the same things, because this is how much most things have gone up. Some went up a lot more, some stayed the same, but in an average, items went up 2.8%. So we need to find his increase. That's just relative percent change. I think I can see it over here. 53,400 minus the 52,000 over 52,000 times 100.
The wrong number for the first one.
Did I write it wrong? Oh, thank you. I flipped my numbers. Should be 53040. Thank you.
I got the number 2.
Should we get 2%? So he had a 2% raise. He had a 2% raise. Can he buy the same thing in 2007 that he bought in 2006?
No.
Because, I mean, it's close. This is 2% and this is 2.08. Money is going to be tight, but it's close. But technically, he cannot buy as much in 2007 that he bought in 2006 because this percent is smaller than this one.
So if the percentage was the same as the one before that, then he would be able to buy more, or
Not more, but the same amount.
yeah.
If it were 3% raise, then he could definitely buy more things than he did the year before.
Oh, okay.
Equal, then he only buys the same amount. So greater than, you can buy more. Less than, you can't buy as much as you bought the year before.
Okay, thank you.
So in this case, money would be tight. If some of the things he could find on sale cheaper in 2007, then he could still buy the same amount technically. But it does make a difference. Any questions on that? So you cannot buy as much in 2007 than he did in 2006. Since his raise is lower than now, if you wanted to put that, like on this one, they are close, so technically he may be able to, money will be tight. But technically that's what you would need. I think you had to state the percent raise, so I don't think I did. Since his raise is lower than the inflation rate. His raise was 2% and inflation rate was 2.08. So you would have to be careful when you're writing it and make sure anything I tell you to have in there is in there. My first sentence didn't have the percent raise, so I added one more sentence to get it in there. Any questions on that? Is there any questions on anything?
I have a question. Sometimes for the absolute change, I don't know why I get confused and I feel like I should multiply. I don't know if or I'm not sure why I think I should multiply when I do the absolute change.
Yeah, absolute change is just subtracting it because you're finding out how much, like the difference between the two, how much it increased or decreased.
Yeah.
And you can have formulas written down. So write down absolute change, new minus old, and then relative percent change, new minus old divided by old. And if you need the percent, you multiply by 100. So write those formulas down. The other formula was rate times time is distance. So there's absolute change. New minus old. Units stay the same. So if we said I was 32 degrees Fahrenheit on Monday. Friday, the high was only 12 degrees. What does the absolute change tell you? And what you want to remember is it's new minus old.
Thank you.
So then if we subtract them, we would go 12 minus 32, which is 20, but it's a negative 20. A lot of the ones we were doing were positive, and so that's why I wanted to make sure I got a negative in there. What that means is it was a decrease of 20 degrees Fahrenheit. So the units stay the same, degrees Fahrenheit. Negative means decrease, positive means increase. Sunday, Friday, temp, decrease by 20 degrees Fahrenheit. But I would have this written, and then we'll do the next one, but I would have absolute change written on your formula sheet. And then a negative tells you it's a decrease. If it's positive, it's an increase. So which way you subtract them matters. This is the older value or the original value, and this is the newer value. The other formula, relative change or relative percent change. Relative change is just the decimal. When you multiply by 100, you get the percent. So they're telling you the same thing. One is a decimal, one's a percent. But it's telling you the rate of change. I usually use percent simply because I think it's easier to explain in a sentence. Relative percent change, new minus old over old times 100. If it just says relative change, then you don't put the 100. So you might want that also. Relative change is this. Relative percent change. Okay, so let's find the relative percent change for this one. U was 12 minus 32 over 32 times 100. I'm not going to put the 100 in. I'm going to show you both values. We'll do the 100 next. So that's 20 divided by 32. So it increased at a rate of 0.625. This would be relative change. When we multiply that by 100, this one is relative percent change. So from Monday to Friday, oh, this should be negative. There should be a negative percent because it decreased by 62%. So the high temp from Monday to Friday decreased by 62.5%. And the relative change would be it decreased by a rate of 0.625. Any questions on those two? So those two formulas, or three formulas, you want to have those written. The other formula rate times time equals distance. And I can't think of any other formula. One plus trick if you want to, and one minus trick, but don't know that you really need to write that as a formula, but you could. I can't think of any other formulas that we use.
Question about the test Friday.
Uh-huh.
Are we allowed to write the formulas down on a separate sheet of paper and use them on the test?
Exactly. Yep.
Okay. Thank
You're
you.
allowed your notes, but I would have a separate paper that has the formulas. That way you don't have to look through your notes. Chances are you're not going to need your notes. But the formulas you won't need. And I just saw another one. Like these ones, when you're dividing, you subtract your exponents, but when you're multiplying, you add them. If you need that, maybe. In scientific notation, that the number needs to be between 1 and 10. Like if you want to write little notes like that on one sheet of paper altogether, you could also, you know how we have the units changing? You could have your, that paper from the first week, the large numbers, you could have that written so then if there was one like definitely going to have miles to feet. And if you forget that 1 mile is 5,280 feet, if you have like the sheet of those little formulas written, you won't have to Google every single little measurement that you don't remember. Also the metric system. If you're not comfortable with that, you might want that sheet on top too. So your formula sheets, that large number sheet from the beginning of class, and the metric system chart, I would have those. You can use your notes, but I think if you have these formulas, you're not going to use them. Any questions on that? So when you're dividing, the formula is b to the m over b to the n. These are your, usually we only use them for scientific notation. I'll put the 10s there. You subtract. And when you're multiplying with scientific notation, you add. So that might be something you want to write down. Do you need to do a problem with these or are you okay? This was we did this in number 8 on the outline.
Could we maybe go over it?
Mm-hmm.
Thank you.
What we have. So we're dividing. We divide the numbers in front. 8 divided by 2 is 4 times 10. And then when you're subtracting with exponents, the bases are the same. They're both 10. You just subtract the exponents. 5 minus 8. We have 4 times 10 to the negative 3. And this would be our scientific notation. In standard form, this is negative. So we start with our decimal and it needs to get smaller. So we move to the left 3. So we're starting here 1, 2, 3. The standard form will be 0.004.
Thank you.
And then if we multiply, what I would probably do is have both. If I was going to make a problem, because usually there'll be probably two to three just basic problems, kind of like your quizzes were. And then the more difficult ones, but one just so we know the basics. So I'd probably put multiplication with it. If we had 6 times 10, okay, well, smaller. 3 times 10 to the 4. 2 times 10 to the Again, we multiply these. So since we're multiplying, you multiply your numbers. When you're dividing, you divide them. 3 times 2 is 6 times 10. When you are multiplying bases, you add the exponent. So it's 4 plus a negative 2. Or 6 times 10 to the second. And the second means to make your number larger by 2 decimal places. So it would be 1, 2, or 600. So this is the scientific notation, and this is standard 600. Any questions on that? Is everyone all right using the rate times time as distance formula?
Could we go over that one real quick too?
Mm-hmm.
Thank you.
Rate times time equals distance. So a clock moves at pretty slow, 4 miles per hour. How long for it to go? 2 miles.
So is the 4 miles per hour the rate and the 2 miles the distance?
Yep.
Okay.
And we'll put our answer in minutes. Okay, so first we'd find our answer. But you're right. If he goes at 4 miles per hour, your rate always has more than one unit. Miles per hour, 4. We're looking for time, and distance was 2 miles. This is in miles, the rate is in miles. If it weren't the same, you'd have to convert some. But the minutes I wouldn't convert till the end. This is miles per hour, so when we get our time, it will be in hours, and then we'll convert it to minutes. First, we set up our formula. Then to solve it, it's 4 times t. So to get rid of the 4, you divide by 4. So t equals 0.5. This would be hours. Or you could just reduce and get 1/2, half an hour. You have 0.5 hours, and we want to change it to minutes. We know 1 hour is 60 minutes. 0.5 times 60 is 30. So we'll take a swap 30 minutes to go to kind of like the Garfield problem that we had. I think it was on the COREC homework. That Garfield problem used to be in an in-class, because I'd have a no calculator part and a calculator part, and that would be on the no calculator part. So something like that would definitely be a problem. Any questions on it? Any other questions? But any measurement you're unsure of how to convert it, like if you don't have the large number, well, you'll have the large number feet. So I think like gallons to liters and all of that is on that.
The only question that I have is I didn't really understand how to do that the green monster thing, with the baseball field.
Oh, okay.
So I don't know if you could like work us through that question specifically or something, but
Sure.
I had a little bit of a problem trying to like answer that.
So the first thing we needed to do was find out how big the green monster was. I don't remember. We'll have to look it up. So if I Google how tall is the monster, the green monster in Fairway Park, he's 30, 37 feet high. How long is it? 231 feet long. I think we also needed how many people it seats. So I will look that up first also.
Back when I did it, we Zachary and I we found that it was like that could hold like 38,000 people.
Well, it's giving me prices. So, what did you say it was?
It could hold like 38,000 people.
I think that's what I had. Oh yeah, 37,300. Okay. So assuming this, and these were given in feet. So the first thing I would do is find the area of this, because we're going to put eggs on it. And area is length times width. And you could have rounded. You get 85,047 square feet. Then when I did it, what I did was thought about just a square foot in there. Because if you think about a square, no, I think I did it. Yeah, that's right. I have a square griddle, and it's 12 by 12. So it's 1 foot by 1 foot. So you want to think about how many eggs you can put in here. Now, some students weren't sure, and they looked up the size of an egg, which I think it was 3 inches by 3 inches. So if we're going a foot, 3 inches, there'd actually be 4 that could go each way. Three, 6, 9, 12. So I could fit, if they're 3 inches, I could fit 3 eggs. And then going this way again, because this is a foot or 12 inches, 3, 6, 9, 12. I can fit. Which means 4 times 4, I can fit 16 eggs in 1 square foot. Now you could have just estimated, technically I can only fit about 8, or not even 8. I think I put, well, maybe 8 sometimes. But if you want some space between them, 8's pretty tight. But if you use what they said online, 16 eggs could fit on it. But it could have been any estimate. I've had students say you can only fit 4 eggs here. I've had students say they could fit 20 eggs. So it was just an estimate, but make a smaller portion of it. So instead of going with the whole square footage, look at 1 square foot. I think I can fit 16 eggs. So 16 eggs per square foot. And I have this many square foot. I put it on top because my square feet will cancel. So I'm just multiplying them. 16 times 547. I can make 136,000 eggs. The stadium holds 38,000 people. I have plenty of eggs. So it just depended on how you estimated this. If you went with a smaller amount, then it may not be as close. Maybe you can't. But this part here was just your own estimate. But you did need to find the area of the blue monster and then assume approximately how many square feet. Any questions on that? It's definitely one of the harder ones. Any other questions? There's definitely one where you'll have to think out of the box like this. And then there's one, make sure you know, well, you don't need to know it, you'll need to look for it. The circumference of the earth, there'll be one probably. I like that problem. I liked the lab where you went to a different planet because you can put a lot of different things with that. Any other questions? Did that help you though? Yeah. Okay. I think on the test it will be a little more straightforward, but we do the number of people on a football field. I don't remember. I think that's everything. Is there any questions? Just looking through to make sure I got all of it. If anyone typed in something in the chat. Any questions? Okay, well, if you do not have any questions, I will see you on Friday. We do have extra time, so if you do have a question, go look over your notes and look at all your problems. If you have a question, send me a text and I will email you right back. But is there any questions? Okay, so you're going to have your, make a list, your 2 tabs up. The inflation calculator and the minimum wage. So make sure you have the links open. Then you want a formula sheet, the large number sheet, and what was the other one? The metric system. So I would have these things, and then if under that you want to have your problems, your homework and stuff like that, that's fine, or your notes. But I would have these 2 windows open, these things on top, and a calculator, or if you want to use the calculator on the computer, you can have that window up also so that you can get back and forth quickly. I don't know if you can see my tabs over on the side. But like I teach at 3 schools, so I have one for each school, so then I can flip back and forth quickly. And that's what you want to do on the test. Oh, and pencil. I prefer pencil because then you can erase instead of when you go to write something, then you have to scribble it out. You can erase it instead. Any questions? Awesome.